I'm Tyson Halsey. I'm an investment manager, chartered financial analyst, and I know the backstory on the company that I encourage to present here, and that is WaferPath. I know one of the founders, his name is Frank Pavlik, but as a money manager, I actually also have a startup and I presented, and I encourage them to speak to you. And I think it's a very exciting story. So here's the backstory. I've known Frank for almost 30 years. And in the summer of 1990, Equip Technologies was a startup with Frank and a couple other people sleeping in their offices in Sunnyvale, California. And by 1998, the company sold for $250 million. And they sold to PRI Automation. What they did is they made robots that go into semiconductor companies. They had 60% market share selling robots to Applied Materials, to KLA, to 10 Core during the PC boom. From 0 to 250 in 8 years was pretty good. This company, WaferPath, is a reiteration, starting with the founder of Equip, or one of the founders, Frank Pavlik. The company was sold to PRI. It had several new owners who tried to build and improve upon their technology, their robot design, and nobody succeeded. Nobody really advanced it. So all their robots have slowly worn out over 20 years of consistent use. And they sold originally about 30,000 systems, with 10 to 15,000 still running in factories today, and they're breaking down and they're old. And so they don't have replacement parts. And everybody who wants to buy a car has been hearing about the semiconductor shortage. And so their average system price is about $50,000. Their addressable market just to replace their original robots would lead to a $500 to $750 million market. Frank, who designed the original robot, has created a new robot. It is unique to the competition in that it is software compatible and plug and play at different fabs all over the world. WaferPath currently is in multiple trials, and the demand for their robots and their pre-aligners at this point is capital constrained. And since the 1990s, when they had their Equip had its first great success, this focused around the semiconductor PC boom. Now it's the Internet of Things, and semiconductors are used in autos. And you're hearing about people can't get autos and buy them because they can't get semiconductors and they don't have the equipment. And so clearly they have a very key role in the whole build out of the new equipment. At this point, I would just say that WaferPath has the experience, the team, and the market. And Harry Edelson is a guy that I've gotten to know. He's an advisor to my company. He spoke at Marty's presentation, and he says, you know, he's had 11 unicorns. He says, you know, you want to invest in the hot areas. These guys have a robot, plug and play, and this could be a winner. So I'm going to pass on to Chen, who is the new CEO, Frank Pavlik, and who I've known for about 30 odd years, and James McCartney, no relation to Paul. Go ahead, you.
Okay. So yeah, good afternoon, ladies and gentlemen. Yeah, thanks a lot, Tyson, for a great introduction of WaferPath. Thanks, Marty, for this for your invitation and opportunities to be here to share with you the exciting journey that WaferPath is taking on. My name is Chen. I'm the CEO of WaferPath. James? Yeah, most of us still remember the panic buying of a toilet paper from last year, right? So you guys know that this is happening in semiconductor as well. because we are in a severe shortage situation of semiconductor silicon chips. I mean, the question is that why can't we just make more? Because it is hard. And making silicon chip is way more sophisticated, and it takes a lot longer to increase the capacities. And so based on my knowledge, most of the semiconductor foundries are seeing more than a year backlog of orders. That tells us that we will not be able to get out of this shortage situation anytime soon. So, well, we all know that money cannot buy happiness, but surely it can build fabs. And to respond to the current shortage situations, and the key is to build new fabs. That's really important. And a lot of companies are investing heavily into building new fabs now. Yeah, the Biden administration sees the silicon shortage a big threat. Strategically, Intel announced $20 billion investment in Arizona to build 2 new fabs, and also just last week, and they announced that they're going to spend another $90 billion to build fabs in Europe. And TSMC also doubled their capital spending this year to $30 billion. Which was a double from last year. They also announced that they're going to spend another $100 billion more for the next 3 years. And the Samsung is also making significant investment into building the fabs. This really tells us that we can anticipate a very strong growth in semiconductor even beyond 2023. So this slide shows some automations that we use that commonly seen in the semiconductor manufacturing facility. Semiconductor manufacturing is getting more and more sophisticated. Most of the tools are equipped with some degrees of automations. And so some of them are robots here. Robots are basically moving wafers from place A to place B, but they move a lot of wafers. So I mean, the robots are extremely important for the semiconductor manufacturing. Simply put, without robots, we cannot make silicon chips. So what are the issues? Well, and the first big one is there are not enough tools, especially in the 200 millimeter space. And the semiconductor manufacturers just cannot expand their capacity fast enough to keep up with the market demand. And at the same time, the two manufacturers are quoting a lead time, which we have not seen in the past 10 years. So there are 2 categories of a province that WaferPath can address. So in the new fabs to be built, OEMs must provide tools compatible with those already in use. But the big challenge is that where are you going to source the old components that were used to design the tools 20 years ago? So our products will eliminate the challenge by providing a solutions that is compatible with the existing design. The second category is that there are many tools running in the existing fabs already. So those robots at the end or beyond their useful life. And so maintenance and service are going to become a big issue because many of the electronic components are obsolete. So with the WaferPath compatible command language, our robots can provide a drop-in replacement of the previous robots. Okay, so the combination of the large influx of capital into the tool market, as well as the products that we have already designed to address these critical issues, present an excellent opportunity of growth for WaferPath. So what is our vision? WaferPath was founded to specifically address these critical needs initially in the 200 millimeter wafer handling space for both new and existing tools. Our products are drop-in replacement for the equipped series of wafer handling tools, which help to preserve fab operators' existing investment in their process. The speed improvement we have made in our tool can increase the throughput and yield when the process can benefit from increased robot speeds. WaferPath robots can also enable future growth by integration into next generation tools, and because we have designed the robots to collect data, which was not done previously, and the WaferPath robots can also enable capabilities not possible with older systems. We are focusing on two the major market segments. The first one is new equipment vendors, and the second one is fab operators, and the last one is repair and service companies. The OEM channel is fertile of the $70 billion reported by the SEMI. The spending on the wafer handling tools, robots alone, is estimated about $1.3 billion. The long lead time quoted by other vendors really gave us a unique opportunity to access to this market. Gaining even a fraction of this $1.3 billion market is going to result in several tens of $1 million of a revenue opportunity for WaferPath. And this opportunity reoccurs with additional OEM spendings in the following years as well. So that's number one. Number two, with the fab operators, we can demonstrate that WaferPath products, are drop-in replacement, enabling fab operators to upgrade their systems without suffering too much or risking the significant downtime. The major benefits of our solution are the reliability and serviceability. The current robots that are in use suffer from unexpected failures, causing unpredictable interruptions in the workflow, and as a result, the operators must frequently refurbish the robots. This refurbishment used to occur on the 5-year cycles, but now is twice as often. And electronic failures on those robots, those old systems, oftentimes cannot be repaired. So when combined with the ability to add the new measurements and data collection without making the host tool software changes, we believe that the benefits for the fab operators is very compelling. So with the as Tyson mentioned earlier, right? About 30,000 of equipped robots were deployed in the market. We estimated at least at a minimum, still the 10,000 of them are still being used in the fabs, and this really represents somewhere between $500 to $600 million SAM for us. And the third segment is to the repair and the service companies. And they perform the refurbishments of equipment that is not surveyed by OEM vendors. And cultivating these vendors provides WaferPath qualified service suppliers in the widespread geography without related front expenses.
Waiting.
So
there's hundreds of people on this. You look amazing. You.
No. Okay. So why WaferPath? Right? And the biggest advantages we see in our solution is that the modifications on the host tool softwares can be more expensive than the cost of the new tool. So that's the biggest advantage of our solution, because it does not require a host tool, the software, modifications, which offers substantial cost saving while extending the useful life of the existing tools. This applies equally to both the OEMs as well as the fab operators. The level of compatibility is possible only when WaferPath was founded by the same engineer who created the original EquiRobot, so as Tyson mentioned earlier. As an early indicator of our success, the WaferPath robot was installed in the production fab environment. And after the setup, the robot processed more than 25,000 wafers without any incident, without any changes in the host software. As we speak, the WaferPath robot is running at another production fab environment. This is the 5th week of a continuous running as part of the customer's qualification process. We anticipate the customer will purchase the robot and expect the repeat orders after that. In a sorter application, because every application can be different, in a sorter application, the measured throughput increased by 27% over the EquiRobots. And the modeling indicates that we could achieve additional throughput gains if we use WaferPath aligner as well. Okay. By using the modern electronics, the WaferPath robot moves the controller inside the robot and it eliminates 10 out of 12 connections, which can improve the reliability greatly. The WaferPath software is designed to be modular and reusable and easy to adapt to the future requirements. The previous generation of robots did not have this capability. Thus, it gives WaferPath a significant advantage in predicting the robot service requirements and thus improve the uptime. So our management team consists of Frank, James, and myself, and I'm the CEO of WaferPath. I've been in the industry for more than 20 years. I was an executive at a semiconductor public company in the US. And so under my leadership, I took the business from the $230 million a year to more than $400 million a year. And so that's about me. I was trained to become an electronic engineer. I graduated from the University of Cambridge with my PhD degree. And Frank Public, he's the founder of WaferPath and CTO. He's an expert in the designing of robotic systems with a commanding understanding of both electronic and the mechanical aspects of the system. He was a co-founder of Equip Technologies, where he designed the robots that the WaferPath are designed to replace. He has over 30 years of experience and in the semiconductor wafer handling field. James McCartney is a software engineer with over 15 years of experience in semiconductor wafer handling software systems and over 30 years of experience in real-time embedded software development. In addition to semiconductor systems, he also worked on mission critical applications like air traffic control radars, atomic clocks, and testing systems for implantable pacemakers.
How many patents have you guys done?
We have done 4 patents so far. We have and a few in the pipeline. Okay, thank you. So this is our product schedule. So basically, if you look at the slide, we have 3 categories of products. And the first category is AR100, 200, and the pre-aligner, and the AR400. So basically, AR100 robot is available for order today. And the AA100 aligners is available for pre-order today with delivery later this year. We plan the volume builds to be towards the end of this year, and the pre-production of the aligner is scheduled in the November, and for the development and testing, as well as alpha customers. And after the testing is complete, a demonstration of AR100 and aligner together will be run in production semiconductor facility. Okay. Our plan for 2022 is augmentation of AR100, because AR100 was mainly for 200 millimeter, and we are going to add the capability onto the AR400 series, so that they can be run on the 300 millimeter tools as well. So
We have time for a couple of questions. Can we get on to, okay.
yeah, so we have
we have about 2 or 3 minutes.
yeah, okay.
Current customer status?
Yeah, current status on the customer front is that it is quite exciting that we are already working with the multiple OEM customers. And the latest is that we have 2 OEM customers purchase orders on hand for pre-aligners to be delivered in November. One of the customers, is pushing us for more aligner to be delivered in January. And also we have an active design-in of a robot and ongoing with another OEM customer. For the customers on the fab side, we've been working with our alpha customer, beta customers, and the progress is looking very good. We are being careful to handle the customer engagement, because we need to raise capital so that we can build appropriate amount of capitals and for our inventory, in order for us to get ready for the production ramp.
How much are you raising?
We are trying to raise $4 million. Okay.
Is there a pre-money, or is this?
That's a pre, and with the valuation of 15.
Okay.
And it's actually going very well and already, and we just started.
Are there government grants for something like this? I imagine it's like a strategic initiative, right?
Well, this is something we are going to go after as well. That's a good point. Yeah.
Okay. This is hard technology, right? So what is the there must be an issue, distribution of the product? Like, are there distributors, or is there only a few purchasers?
So we will do ourselves at least for now, and because there are a lot of fabs, there are a lot of OEMs. Which require a lot of like a hands-on interaction with them. So we know our products the best. At this point, we are going to just do the direct sales.
Okay.
Okay.
Any other questions?
So, okay.
What percentage of the wafer capacity is 200 millimeter as opposed to 300 millimeter?
Oh, that's a good question. I don't know the answer for that, but what I can share with you is that the capacity on 300 millimeters has been, kept growing, but the growth on 200 millimeters has been very limited, because it has been under investment for the past few years. But now you are seeing all the automakers are crying for capacities, where are my chips, so forth. A lot of those chips, like the power management, sensors, so on and so forth, they can only build with 200 millimeter equipment. They cannot be built with 300 millimeters. So smaller percentage, but it's still a huge chunk. Okay. So
let me ask from a national defense standpoint. I've said in my board meetings many times that people ought to either find their old slide rule or an abacus, because if Taiwan gets taken over by China, either violently or just through pressure, we'd be really, really in bad shape. So in terms of the production of the semiconductor factories now in Arizona, it seems like this would help jumpstart those and really gear up production.
Yeah, definitely, I agree with that. Just my personal opinion, right? A lot of people I mean, Intel tried to do foundries many times, and they didn't do it successfully. But now it looks like the prime time is coming for them, exactly because the reason you just mentioned. I mean, those are really critical. The strategic topics for the United States. Absolutely.
InQtel? Have you spoken to InQtel?
No, I'm not.
I think the most important point here,
Yeah, I
Mark,
think Intel does that, yeah, they look at that, maybe I'll trade cards.
Hey, I don't see you. Are you logging in?
We're gonna have somebody from InQtel,
What's wrong?
speak tomorrow.
Oh, okay. Okay, sounds good.
Matthew, mute yourself.
So,
Oh, yeah, you got to come in right away.
okay.
Thanks.
Okay,
Got
so
one more minute.
yeah, so that based on what we are seeing now, the company is projecting a CAGR of about 80% over the next couple of years from now until 2025. In 2025, we think we're going to do $20 million a year in terms of revenue, with a gross margin of probably 10 million and operation margin of 4.5, like what Marty mentioned just a little bit earlier. And we are trying to raise 4 and for the valuation of 15. And on the screen you are seeing you probably saw that our robot was running. So basically that this robot needs to move wafer from position 1 to position 2 for a lot of things. I mean, almost anything that you will need a robot to move wafers from position 1 to position B. So I mean, the potential is great and the opportunity is great for us.
Fantastic, you, great job.